Here we're going to talk about writing equations of lines and what all that entails. Now, most of these equations that we're talking about right now, we're looking at linear. So in order to write the easiest equation, we want to use your slope-intercept form. So slope-intercept form here, y equals mx plus b. Again, where m is your slope and b is your intercept point. Now, we have to remember intercept points are always going to be the form 0, y. So what we're going to look at is a bunch of different examples of all different forms, and each one gives you all the information you need to write an equation. You just simply have to be able to pull out the necessary requirements to give you this slope-intercept form. Okay. So here we have that you're passing through the point 0, -3 and have a slope of 2/5. So this point here is actually your y-intercept. Therefore, you just simply have to go straight to y equals mx plus b form. So here this is going to be y is, my slope is 2/5 x plus my intercept here is the -3. So now you have plus a negative, so we like to condense that down. So y equals 2/5 x minus 3. And this is the equation of your line. Now this next example, we just simply have a graph. So what you want to do here is you want to identify 2 points that you can use in order to find your slope, and then hopefully one of those points or a different point would be your y-intercept. So here, when we're looking, this first point here is at the point -1, 0. And the second point here is at the point 0, -3. So 1, 2, 3. Now, the other thing to notice about this point is that this value right here is your b value. So the first thing that we have to do is we have to calculate your slope. So we have that m is y2 minus y1 over x2 minus x1. So we have to decide which is which. It really doesn't matter. So we can say x2, y2, x1, y1. So we need to plug our values in. So we're going to have 0 minus a -1 all over -3 minus 0. So when we simplify that, we get 1 over -3, and that is your slope. Okay, so this is the slope that we're going to use. We already know our b value, so we can write our equation. Y is equal to -1/3 x minus 3. And here is the equation of our line. Alright, let's look at a couple others. So again, here there we go. So here you can see that we definitely are crossing through our 2 points here. This first point is going to be at the point 0, 1. And the second point here is going to be at the point -1, 0. If we pay close attention, this right here is your b value, and we have to find your slope. Well, here, very simply, we could start at this point, and we could simply go up 1 over 1, and there would be my slope. So I would have a slope of 1. Now, we can prove that by plugging into our slope formula here. So we could have x1, y1, x2, y2. So we're going to have 1 minus 0 all over 0 minus a negative 1, which is the same as 1 over 1. Therefore, the equation of my line here is going to be y equals x plus 1. Now the other one that I have here, notice, is going to fall under my special case. This is a vertical line. What we know about vertical lines is they are x equals equations. So here we simply have to look at what is the intercept that we are crossing at. Well, this point here is going to be the point 3, 0. Therefore, because this is an x-intercept and a vertical line, remember your slope here is undefined, which means we have an equation x equals 3, and this would be that final result. Now, the last way that we could see these problems would be in application problems, kind of like this one here, where it says that the number of people in the U.S. with mobile cellular phones was about 180 million in 2014. So here, 180 million in 2014 could potentially be your first coordinate point. And then about 286 million in 2009. So we potentially have 2 points set up here. If the growth in mobile cellular phones was linear, what is the approximate rate of growth per year from 2004 to 2009? So we do. So what we're going to do is we have that x is going to be represented of the years, and y is going to be represented of the people, and this is going to be in millions. So here what we actually have is we have the coordinate point 2004 and then 180. Now notice I'm not actually writing out 180 million because that's a lot of zeros. Instead, by making this statement here that we are in millions, that allows me to just simply use the digit that you see. So this is why I'm only using 180. Now the other point that I have is I have the point 2009 and 286 million. So now I can find my slope, and so here I can do 286 minus 180 over 2009 minus 2004. And when I do that, the easiest thing for you to do first is you're going to want to reduce your top and reduce your bottom separately. So this is 106 over 5. And then you want to look to see how does this reduce at all. Well, 106 over 5 is not going to give you anything pretty. Instead, what it actually gives you is about 21.2. And so here, if we want to actually chart it, we're going to have years down on the bottom, and we are going to have people coming up the top. So again, just like before, I would go ahead and use the bottom part and the side part. And then we need to kind of create our stuff. And so we are talking about 2004. So we would use that as like your starting point. So 2004. And then we can go 5, 6, 7, 8, 9. So we've got 2005, 2006, 2007, 2008, 2009, 2010, and so on and so forth. And then going up the other side, we might go, let's do, so 25, so here would be 50, 75, 100, 25, 50, 75, 100, 25, 50, 75, 100, 25, 50. Okay. So what we have to graph is we have to first graph the points that we have. So we have the point 2004 is 180. So this is 150, 175, so 180 might be right around there. We then need to do the second point. So this is going to be 2009 at about 286. So 2009 is going to be this line here. Here's 250, 275, about 286 might be somewhere around there. So we would connect these points kind of to the best of our ability. So notice that this is still a slight approximation. So we would connect those points. And what we want is we are trying to find the rate of growth per year. So essentially we found that when we did our slope. But we're trying to do it on your graph. And so if you pay attention, our slope is saying that we would go up 106 and over 5, which is very, very, very hard to see. But we're also going up 21 over 1, which again is very hard to see. But we have our slope here. This value is actually going to be your approximate rate. So your rate of growth is approximately 21.2, and then we are talking about million per year. Okay, so that is kind of what you would have to do when you're working with your problem, is you have to be able to answer the question that you were asked. Now, the other piece that you have to remember is when you made this designation in the beginning, because a rate of growth is talking about your change per individual year. Now, if we look at this slope here, we are talking about per 5 years. So you have to pay close attention. The top number here is talking about the millions of people. The bottom is per 5 years. I want to know per year, and I'm told that here in my problem, growth per year. Okay. So to do that says we have to finish the division, and we need to remember that it was in millions. So in a nutshell, that is what you would need to know in order to work with writing equations of lines, specifically working with your slope and your y-intercept. So if you have any questions, please let me know. Otherwise, remember to keep smiling. Have a wonderful day. Enjoy your math. Be creative, and I'll see you next time.